Slicing your data set. Now let's look at how we can slice your data set using the Numpy package in R. So we want to see how we can slice our data set using the Numpy package in R. What do we mean by this? Now, in slicing the array of your data set, we said we have different types of data set. Data set could be in a list. We've seen how to create a list. We've seen how to create a tuple. We've seen how to create a dictionary. We've seen how to create now an array. Now, in order to slice your array of data sets using the Numpy package in R, that's what we want to look at. Now, using the Numpy package in R, it helps you to slice your array data set. In other words, it helps you to print only part of the data set. If you're interested in only printing part of the data set, it helps you to print just only part of that data set. Now, slicing arrays. Now, slicing in Python means taking elements from one given index to another given index. That means that you have 5 data sets or 5 elements in your array. Now, I am interested in just only the first 3 elements. Now, you can tell Python just print only the first, second, and third elements and leave the rest data sets. Yeah, because they are not just subject of interest. So, how you can do this using the Numpy package in R. Now, we pass slice instead of index. Now, we pass slice instead of one index, like the start and end. Now, we look at this particular we look at whenever we want to print, we used index 1 minus 1. Or whenever I want to print, we used we tell Python to print this. Now, this is our object. That is the name of our data array. Now, we tell Python print 0, 1, 2. Or we tell Python print 0, we make use of the index. But when you're using you can also print your array without using the index. And you can slice your array without using the index. So instead of using the index, you can just use the start and the end. We can also define the step like the start, end, and the step by providing the starting point, the end point, and tell Python after the first 2 digits or after the first 2 elements, you can print the data set. So if you don't pass the start, it is considered as 0. Python consider that as 0. So if you don't pass end, it's considered it's considered length of the array in that dimension. That if you don't give it an endpoint, it's considered the whole length of your array. That's what Python is going to use. Now, if we don't pass the step, it's considered 1. So if we don't, by default, Python is going to do it. It's going to take it by 1. Now, let me explain what I'm talking about. Let's look at this example. Slice elements from index 1 to 5 from the main array. Now, I want to look at this main array. I want to slice this element from 1 to 5. Now, you can see import Numpy as NP. Now, we're giving this is our array. Now, we're giving this array a name. This will take any name which we said earlier on. We've established that fact equals to np.array. This is array. Now, we're interested in printing just the first 5 elements. So, we tell Python print. When we tell Python print array, it's going to print everything. But when I tell Python, we just need only the first 5 elements. Python is going to print the result, including the start index, but exclude the end index. Now, in this particular case, we are still using the index. So let's see this before we go ahead with. Let me quickly click on this. Now import Numpy as NP. Okay. Now we are telling let's give that equals to, we can give that any name. We could call that an array. We could call this any name we want to give it. NP dot array. Now, but that is a package. Now we have 7 there. Now we can say print. Now I tell print this. Python is going to print all that. Now you can see Python print all the elements. But if we want to slice this array, we can tell Python, okay, we want to slice this array, print from one element 1 to 5. Slice the array. So Python is going to print 2, 3, 4, 5. Omitting 1, the 1. Because we told Python print 1 to 5. This is considered 0. This is considered 1. So it starts from there. But if we tell Python to print from, then it starts using the index. That's it. Python is going to start from 1. They're going to slice the data set. Now, in using the Numpy function, we can now use what we're saying here is this. This particular we are saying we pass slice instead of the index. You can use the start end instead of index. Okay, now let's continue. Slice element from index 4 to end of the array. Now, if we want to start from the fourth element, we'll tell Python that to the end, we are interested in slicing that data set. Now we can see from the fourth element 1, 2, 3, 0, 1, 2, 3, 4 to the end of that. So it prints all that. Now, using the negative slicer, use the minus operator to refer to an index from the end. They want to print an index from the end. So slice from the index 3 from the end to index 1. Now we are starting from the end there. So that is what we want to start from the index 3 to index 1. So this is considered minus 1, minus 2, minus 3. So we want to print from this up to this point. So from 5, 6, 7. So what we are going to do, up to minus 3 to minus 1. So that is minus 3, 1, 0, 1, 2, 1, 2, 3, minus 3, sorry. 1, 2, 3, minus 3, minus 2, minus 1. So Python going to print 5 and 6, omitting the last number, omitting the last word, the last element in that particular word array. Okay, now let's see now return every other element from index 1 to 5. Okay, now let's see this. Print from 1 to 5. Use step 2. Now I tell Python to print from index 1 to the fifth index. This is 1, this is 0, 1, 2, 3, 4, 5. To the fifth index, we are telling Python to print it in stepwise, two digits in stepwise. That's what we are telling Python. So we are telling Python to include the step 1 is to 5, then we include the step. So this is starting, this is the end, and this is the step. I tell Python to print. Now you can see this is 0, this is 1. So 1, 2, 3, 4, 5. 0, 1. So 1, that's 0. So Python starts from 0, starts from 1. Then it omits, we said 2 steps ahead. It omits 3 and print 4. Then it omits 5. So we said 2 steps ahead. So it starts with 1. This is the starting point, and it's going to omit. We said omit because we said stepwise. Do it this way. Step Python stepwise. um, to 2 stepwise, Python should omit this. Then it goes to the fourth element, that is 1, 2, fourth element. After giving out the fourth element, because we said stop at 5. So this is 0, 1, 2, 3, 4, 5. And then we'll tell Python stop at 6. So when Python gives us the first element 2, like 1, 2, it counts 1, 2, it gives us 4. We're going to count another 1, 2, and gives us the next element. So after giving us 4, Python counts again 1, 2, and gives us what? 6. So if I happen to add another element here, 8, 9, 10, and I tell Python, okay, I need 2 elements, let's make it to 8. So you can see Python counting that. After Python counts 1, 2, gives us 4. Python counts another 1, 2, gives us 6. Python counts, when I count another 1, 2. After 6, it's going to count 1, 2, gives us 8. But with that stepwise, it should give us elements for 8. Okay, now when we have something like this, return every other element from the entire array. Now what we're trying to do here. Tell Python, okay, we want you to return every other element in the array. So we use the colon and return all the other elements in the array. 1, 2, 3. Okay, it omit 4, 6, 8, and 10. So it returns all the other elements in the array except the element that are even numbers. So now we are telling Python again, bring out all the odd numbers in this particular array. Now let's see slicing the 2D array. From the second element, slice element from index 1 to index 4. 4 is not included. Now we have 2 array. We have 2D array. Now this is the first array. From this point to this point is the first array. From this point to this point is the first array. Then the second array is from this point to this point. That's the second array. Now we're telling Python from the second element, slice elements from index 1 to index 4. Because 1 is already the second element. Now we're telling Python slice that. So we're telling Python the first row, the first row, the, the first row, the second element, which is 2. So give us this, this is the second element, that's 1, this is 0, this is 1, 2, 3, 4. We're telling Python gives us from this 2 to 5, which is not for 2 to 5. Give us that element in this particular row. So let's try that here. Okay, let's make this okay 10. Now I have that. Now let's bring all into the array. Okay, now let's tell Python to print this 1 row 1. The start from the second element. If we are starting from the first element, it has to be 0. So from the second element, that is 1, 4. Okay. Remember the second element has an index 1. So let's run this. Now you can see um, Okay, sorry. Um, this is we are turning Python from the second row. Now this is the first row. The first row is indicated with 0. This is the first row. Tell Python to point from the second element to the fourth element. So 0, 1, 2, 3. That's 1, 2, 3, 4. That is the fourth element. So we are telling Python start from 1 to 4. We call that the first element is indicated as 0. The second one is 1, 2, 3. That is the fourth element. So we are telling Python we print 4 elements, but start from 1 to 4. So 0, 1, 2, 3. 0, 1, 2, 3. So this is the fourth element. From this point to this point, that's the 4 elements. So the first element 1 takes an index of 0. The second element 2 takes an index of 1. The third element 3 takes an index of 2, while the fourth element takes an index of 3. So we are printing, telling Python to print from 1 to print from 2, 3, and 4, just to print only 2, 3, and 4. So but when I indicate this as 1, I'm telling Python print the second row. This is my second row. This represents the second row. So I'm telling Python print from the second. So this is how you can slice your data set. You don't want to print all the data sets in R. This is how you can slice the data sets. Okay, you can also use from both elements, you can slice index 1 to 4. This will return the 2D array. Now you can see now this is 0, that is from the first row. You're telling Python from the first row. You're telling Python from the first row. I want you need to get the 0, 1, 2. You need to get the second element, which is 2. And from this other row, you're telling Python that Python should pick um, 1 to 4. We have 0, 1, 2, 3. We need 4 elements. So 1, 2, 3, 4. These are 4 elements. So recall that 6 takes an index of 0, 7 takes an index of 1. So Python is going to print 7, 8, 9. So let's try this and see. Now you can see. So Python 7, 8, 9, and Python print this order. So that is that. Now Numpy datasets and Numpy datasets, they have data type. Now we have just like in Python, we have a different type of data set. This is a package in Python. Though we have different type of packages in Python. We have the Numpy package, you have the matplot package, you have the matplot, Numpy, you have the Numpy, you have Micro, you have matplot, we have the skip lane, and that matplotlib, matplotlib, we have the skip lane, and then we have the other packages in Python which we are going to learn. So now let's look at data type and why is it package in R. Now we have the string data type used to represent text data. The text is given on under quotes mark e.g. A, B, C, D. We have the index. Also, we have the integer represented by -1, -2, -3. We have the string represented by the character, the text character. We have the float data type that is used to represent decimal value. We have the boolean data type which is takes the value of true or false. We have the complex data type. So let's look at the data type in Numpy. So Numpy has some extra data types and refers to data type with one character like I for integer. I represents integer, U represents unsigned integer. Now these are the various letters that represent the different types of data type in Numpy. I represents integer, B represents boolean, F represents float, C represents complex um, float, and X represents string, and so on. Now let's look at the Numpy, checking the data type of an array. Now you have an array, you can check the data type just as we. It's the same thing within in Python, we can also do it. So the Numpy array object has a property known as the type. It has a property known as what the type that returns the data type of the array. So we'll make use of the type, it returns the data type of an array. So let's add this here. So let me simply copy all this. I import numpy as np. So let's call this add. Let's just keep that the np dot array. So that was it. Now this is the array 1, 2, 3, 4. Okay, now we have this. Let's print. So we do that. Now we bring this name. That's our object. Now dot the type. Now this will display what type of data set, what type of data type is this array. So that tells us as an integer data set. But when we do it this way, let's say point 1, 2, let's say point 4, and point 5. I want to see the array take on exactly its float data type. So that using the data type property helps to determine the type of array we are working with. So that shows us the type of array we are working with. Let's look at this particular case here where we have this. What's Numpy? And we call this so now I make use of Numpy, so I have to use the Numpy dot okay. Okay, the type. Now it's telling us you, okay, that in the character type is giving us that as the character type. So let's go, that is telling us Unicode string. Now the data type there is, we are looking at there is the Unicode string data type. That's what it is telling us there. That's the Unicode string data type. Okay, creating an array with a defined data type. We use the array function to create arrays. This function can take an optional argument type that allows you to define the expected data type of the array. Now we import Numpy as np array equals arg equals to this. Now we've changed this instead of this particular data type. Recall this gives us an integer. But we want to change this data type by using the data type and specify x. In other words, we are saying that oh, let this to be a string data type. Python should bring it out as a string data type to make use of x. So bring it as x. So print this, print our array. I'm going to print it, and when I say print this, we want to see the type of data type it is. It tells us it is string data type. Now let's look at it. Now we look at this particular case here. We call when we print the data type here. Now, when I print this particular data type, it is giving me that the data type is integer. But if I don't want that to be that, I want it to be string data type, all I need to do is to use the type property. And I include this as an argument in the array function. This array function, I use the type property, the type property. I pass it as an argument in the array function. So I'm going to pass it as an argument in the array function. I represent it with S. S represents string data type. Then I tell Python print this. Now you can see it's telling me S. It's giving me X. That means it's a string data type. So if I want to print the array, I can now type in say print. That if I'm interested in printing that. So Python is going to print the array. Now it prints out the array and then it also uh, prints the data type that is telling me that is string data type. So that's how to determine the data type in how to change the data type in Python. But what if the value cannot be converted? There will be a situation whereby you cannot change the data type. If a type is given, which element can't be can't be casted, then Numpy will raise a value error. In Python, value error is raised when the type of passed argument to a function is unexpected or incorrect. So now this argument I pass in this particular array function, if Python does not expect such arguments in this particular function or is incorrect, it's going to raise a value error. It's going to raise an error, and that error is a value error. That means a value that is passed as an argument is incorrect. Okay, now you can let's look at this. We take this particular example, you can see this will raise a value error. Now, we use the type function. We want to change this data type. We want to change it to all to integer. Now, you can see there's going to be an error. That's a value error because it does not expect the, the A in that particular as part of the element there. So the best way to convert a data, um, the best way to convert an element in an array is to use the as type method. The as type method is the best way, or the as type function is the best way to convert data in Numpy. We use the as type function. Now, when we look at something like this, um, in using the as type function, you first and foremost copy the array. Now you can see array does as type I. These are array. Now we give it a new name, new array. So we say this array dot as type I. So this array as type copies this particular array, and will now as change, try to change, convert the data type from a float data type into an integer data type. So that is the best method in converting or changing the data type in an array or in the Numpy package of R. So, import Numpy as NP. Okay, arg equals to np dot array Now you can see Python has converted data type from a float data type to an integer data type. So the best way to convert the data type from one data type to another data type is to use it as type method. The type method is best in converting that. Use the type method helps to convert the data type from one data type to another data type in the Numpy package. The random number in Numpy. We can generate some random number in Numpy. So Numpy also can help to generate random number. Now, Numpy offers the random model to work with random numbers. Generate a random integer from 0 to 100. So in order to generate a random integer from 0 to 100, we use the random function in we use the random function in R to do that. So first and foremost, we have to import Numpy. Import Numpy. Then from Numpy, import the random function. So import Numpy. From Numpy, we import the random function. From Numpy, import the random function. Import the random function from Numpy. So let's represent the random number. Let the random number be x. We put out the random number. Let's say we are talking about random number. Okay, let's say let the random number be Rn, random number, and we have the random dot rand. Now we are telling um, Python bring a random integer. This is a rand function, and we are saying let it be an integer of 100 number. Let the size of the random number be 100. The other was bring within 100 numbers. So that's what we are telling Python. Okay, name x is not defined. Sorry. Print now print rand. Okay. Now we said print a random number. Print a random number from 1 to 100. Between 1 to 100, just print a particular number. So that is printing 57. So the earlier on I said 100. No, we are telling it's not printing 100 numbers. We are telling Python between 1 to 100. Print a digit for us. Print a particular digit. Print 57. As you run this code all over again, it will print another number. If I keep running this particular code, they keep printing another number because we are telling Python print a random number between 1 and 0. If I should print, for example, Python, if I should put 10 here, I'm telling Python print a random number between 1 and 10. Print a random number between 1 and 10. So when I make this to be 30, I'm telling Python print a random number between 1 and 30. So each time I run this code, it keep pointing different random number between 1 and 30. It will not be more than that. So, but when I make this to be 100, it prints the random number between 1 and 100. So that's what generating Python. So we are generating a random number using the pin function in R. Okay, now the random model ran, the ran method which we just used. Remember we use ran integer. We are saying the random number should be an integer. The run method returns a random float between 0 and 1. But we just make use of this rand function. The rand function it will return a random float between 0 and 1. Okay, you can see here I mixed the rand integer. But the when we use this to be instead of a rand integer, we decide to use to make it to be a rand. It will return a value between 0 and 1. Okay, it returns value between 0 and 1. Okay, you can see. So each time I run this, it keeps displaying different random number between 0 and 1. But the moment we said run integer, okay, we identify within an integer number, run it, sorry, an integer number between, if it's an integer number, we can tell it between 1 and 10, then it gives us that. But the moment we just make it to be rand, it's going to specify 0, it gives us a random number, a float number between 0 and 1. Let's look at this. A number will work with array and we can use the methods from the above examples to make a random array. Now, the randint method takes the size parameter where you can specify the shape of the array. Okay, to generate a 1D array, a 1D array containing 5 random integer from 0 to 100. Now here we are specifying the size. Okay, this is our case here. Now we have this random integer. And we are looking from Numpy import random and x equals to rand integer. Now we're saying 100. Now that is give us an integer value between 1 and 100. Now if we want to put size, we can say okay, how can a size equal to, let's say I need 10, or let's say I need 30. Okay, just give me 30. So that will give you 30 um, numbers, 30 random numbers between 1 and 100. So that will give you a random number between 1 and 100, give you 30 random numbers between 1 and 100. So that is if we pass the argument size in the rand integer function. So we'll pass the argument size into it. So this is the we're telling Python give us a random number between 1 and 0, give us the size, give us up to 30, like we're telling Python give us 30 digits or 30 numbers. So we can also pass other arguments uh, in this particular function, rand integer function. Okay, yeah. Now we are telling Python, okay, generate a 2D array with 3 rows. Each row contains 5 random integer between 0 to 100. 5 random integer between 0 to 100. So between 0 to 100, and we need the size, we need 5, and give us a 2D array with 3 rows. So I will telling Python here, 3 rows. Okay, now size 3, 5. So just each row should contain 5 random number 1, 2, 3, 4, 5. So we are telling Python we need 3 rows, that means 2D array. 2D array. So that's the first um, row, second row, and the third row, each containing 5 random number between 0, and 100. Okay, now the run method also allows you to specify the shape of the array. So it can generate 1D array, just 1D array, and just with the run. Remember, run gives us a float between 0 and 1, and then we can just type 5 there. Okay, here we are telling Python we want the run. Okay, and here, instead of leaving this empty, we want to specify 5. So 1, 2, 3, 4, 5. Gives us a random value between 0 and 1. And we tell Python to just need only 5 numbers. Python will print just 5 numbers. Okay, yeah, we have 2D array. Now we are looking at 3 rows, and each row containing 5 elements. Okay. Now we can also generate random numbers from array using the choice method. The choice method also allows us to generate random number from array. Instead of random rand, we can use random choice. So return one of the value in the array, random choice. So how it's going to pick just a single value from this particular array. So now you can see. So now we are telling Python just among this number, just randomly pick a particular number from this number. Now we are telling Python pick a particular number from this number. So now we are telling Python to do. Now we have 2D array. Now we can this 2D array that consists of value in the array parameter. From Numpy import this random choice. Repeat this and size this. Okay, we're looking at the size. Now we're telling okay, now there's 3 rows and 5 digits for each array. Okay, now let's look at we're going to wrap it up here. Um, what is data distribution? Random data distribution. Data distribution is a list of all possible values and how often each values occur. Now it's talking about a distribution of data sets, how data sets are distributed in a particular manner. It's talking about the distribution of data sets and how often a particular data set appears. Such lists are important when working with statistics and in data science. We are entering into data science now because of the foundation. We are going into the random distribution. A random distribution is a set of random numbers that follows a certain probability density function. Probability density function. A probability density function, a function that describes a continuous probability. Is the probability of all values in an array. A probability density function is a function that describes a continuous probability. That is the probability, the possibility that a particular number is going to appear in the array. That one we are just talking about before that. So we can generate random numbers based on a defined probability within the choice method of the random model. The choice method allows us to specify the probability for each value. The value is set by a number between 0 and 1, where 0 means that the value will never occur and 1 means that the value will always occur. That means a probability between 0 and 1. Probability is normally between 0 and 1. 0 means that incidences will never happen. For instance, what's the probability that it's going to rain tonight? It might rain and it might not rain. So if the probability is 0, that means it's not going to rain. If the probability is 1, that means definitely it is going to rain. It's certain that it's going to rain tonight. But if the probability is between 0 and 1, that means it might, if it's around 0.7, 0.70, or if it's around 0.70 or 0.8, that means there's likelihood that it's going to rain. So it's more likely that it's going to rain than it's not going to rain. But if the probability is something like 0.4, 0.3, the probability that it's going to rain tonight is 0.3. That is very, very low. Not is closer to 0. So that means there's every likelihood that it's not going to rain. Now let's generate a 1D array containing 100 values, where each value has to be 3, 5, 7, or 9. Now, we want to generate a 1D array and we need 100 values. The value should be between 3, 5, 7, or 9. So the probability of the values to be 3 is set to be 0.1. Probability for the value to be 3 is 0.1. Now we want to generate 100 values. And these 100 values should be between 3, either 3, 5, 7, or 9. And it should be 1D array, just on a particular straight line. Just one, we are interested in just one row. And the probability for the value to be 5 is set to 0.3. Probability for the value to be 7 is 0.6, and probability for the value to be 9 is 0.7. Okay, now let's do this. Random number equals to random choice. Okay, now the number we're interested in is 3, 4, 5, 7, 9. Okay, 4 is not included. 3, 5, 7, 9. So these are the numbers we're interested in now. The probability that the number is equal to 2, 0.1. Probability that the number is 0.3. Probability that the value is 3 is 0.1. Probability that the value is 5 is 0. Probability that the value is 7 is 0.6. And probability that the value is 9 is 0.7. Okay, now size. We are interested in 100 numbers. Now you can see that gives me the value. But if on this we omit the probability, just tell omit this argument. This probability argument is omitted, and we run this. Now, okay, let me do it this way. Now you can see the probability that the number is 0.6. Probability that the number is 7 is high. That's why we have more 7 in this. Well, when we increase this probability to 2, we have lesser 7. Okay, let's say 4. No, 4 is still high. 4 is still high. Yeah, we're having an error because let's say probability for the value to be 3 is 0. Let's say 7. So let's say 0.5. The probability for the value to be 3 is 0.5. You can see 0.5 is high. When you add all this together, it gives you 1. 0.5 plus 0.3, that's 0.8. 0.8 plus 0.2, that is 1. So now when you run that, now you can see we have more 3's. That's the probability. Okay? Now that is that. But if we omit this probability, let's see. Now omitting all the probabilities, now we don't every number has an equal chances to be included in the group. Now you can see we have like almost equal number. The number of times 3 appears is almost the same thing like the number of times 5 appears. It's also almost the same thing like the number of times 6 appears. Now let's as we run as a wrap up, let's look at number the number distribution. And the number distribution is one of the most important distribution in statistics. It is called Gaussian distribution after a German mathematician known as Gauss. Gauss. That's actually found this number distribution. In number distribution, the number are distributed around their main value. So it will give us a kind of bell shape. So it gives us a kind of bell shape. And it tells you that the number of times each number occurs, or the number that the distribution of the number are closer to their mean value. Now it fits the probability distribution of many events. Use the random number method to get a normal distribution, to generate a normal distribution. It has 3 parameters. We have the log, which represents the mean, where the thickness of the bell shape is being determined. We have the scale, which talks about the standard deviation or how flat the graph distribution should be, and we have the size. Now the shape of the return array. So example, generate a random number of size 2 by 3. Now that's the size, the shape of the return array 2 by 3. Now 2 rows and 3 columns. So here from Numpy import random x equals to random dot normal. Okay, x equals to random, but we use the normal one method. Okay, that's use the normal method. The normal method will pass the argument size, say 2, 3, to generate this random number. The size should be 2 by 3 array. Okay, row 2 column 3 array. Okay, from Numpy, attend Python, import that. Let's call this random distribution. Random dot normal. Now make use of the normal method. That's the function, the random dot normal method. Now we pass the argument size. Pass argument size, and we said the array should be 2 by 3 array. Row 2 column 3 array. That's print a random number. Now you can see row 2 column 3 1 2 3. Now it gives us normal distribution values between 0 and 1. So there's a point where you can also specify the type of number you want. You want the number because now we can talk about the thickness. Remember we said the thickness represented by the log. This represents the thickness as the main value. So we can use that to determine the thickness. So here we can now come here and say, okay, we want you to include the thickness here. The first argument log equals to 1 in comma. Then we talk about the scale equals to 2. Now recall we said the scale represents the standard deviation, how flat the graph should be. Now a normal distribution should have a mean of 0 and a standard deviation of 1. That is a normal distribution. Now when you plot this particular distribution, you can see distribution. Now you can see that the, the, the mean 1, all the values are close to 1, and then we have the scale, that's the standard deviation of 2. So that is the value shouldn't be um, higher than 2, shouldn't be that too much higher than 2. That's one scale is not that much. But we say scale of 1, the highest is scale of 2. Now, but once we generate a 2 by 3 rules, once they run up the 2 by 3 rules, now 2 row column 3 with mean of 1 and standard deviation of 2. That's the scale. Now, we are going to stop here. Now, we want to visualize this normal distribution. We want to draw a curve with this normal distribution.